Dear students, I hope you have now remember the control structures we have learned. Can you remember them? We have learned three control structures. They are sequence, selection and repetition. Now today we will further learn how to solve a problem using a computer. Now, what is an algorithm? I hope you remember that also. An algorithm is an ordered set of instructions which we use to solve a problem. Okay. In computing, we represent algorithms using several ways. We have to learn basically two ways of representing an algorithm. We can represent algorithms in two ways. What are they? First one is as a flowchart. Flowchart means we use some graphics, we use some symbols to indicate the flow of a problem. Now remember, what is an algorithm? Ordered set of instructions we use to solve a problem. Now in a flow chart we use some symbols to show our instructions, and also there are more things. We start a flow chart using start and we end a flow chart using stop. That is one way. The next one is we can use pseudocodes. Pseudocode means we can use text. We don't use symbols or graphics, we use text there. And also if we use pseudocodes, we start it with begin and we end it with end. These are basic differences between flowcharts and pseudocodes. In your exam, you will be asked to draw a flowchart, or maybe you will be given a flowchart and you will have to write the pseudocode which matches to the given flowchart. First, we will learn how to draw a flowchart. In flowcharts, you have certain symbols. You may have seen the symbols. These symbols are in your textbook. Now, why do they have given you certain symbols? Because these symbols we can say is a kind of a language. Every programmer or persons related to this computing, when they see these symbols, they know this is the symbol for start or end. This is the symbol to indicate input or output. So we have to draw these symbols very correctly. We just can't draw them as we like. We have to learn the symbols and we have to use the symbols very appropriately. So in order to indicate start or end, we use the symbol. We can say this is a rounded rectangle. We draw a rectangle and along the edges we have to make it round. So we call that as a rounded rectangle. So in a flowchart, to indicate start and end, we use the symbol rounded rectangle. Then you remember, in a problem we have inputs, processes and outputs. So we know how to indicate an input and an output. And then for input or output we use a parallelogram. Then for a process we use a rectangle. And can you remember, we learned the control structures. To indicate our selection or decision, we use this diamond shape with the, can you see there are two arrows connected to that diamond. So we use that symbol to indicate a decision. And for the flow direction, data flow, we use these arrows, and as the final symbol we can use a circle to indicate a connector. So, you will be using these symbols when we draw flow charts to represent our algorithms. Okay. Now, you will be given a certain algorithm. Now, think how can we represent this algorithm using a flow chart. So, how can we do that? First, we have to input two numbers, add them together and assign to total and display total. So, how can we do that? First of all, we have to draw what? We have to have our start. So, how can we draw? First of all, we have to draw our rounded rectangle. That symbol has to be there, rounded rectangle, and we have to say, now I am going to start my algorithm. So, you have to write start and you have to include that within the symbol we use to indicate start. It is a rounded rectangle. Then I have to show the flow. I can show the flow using what? I can show the flow using an arrow. I can use an arrow and use the program flow. Then remember, this arrow should be connected to the symbol I have used. Otherwise, there won't be a program flow, there will be leaks. So, you have to connect those symbols with the arrows. Now, I have to indicate I am going to input two numbers. So, what is the symbol I am going to use? I am going to use a parallelogram to say I am going to input two numbers. And you have to say input, input, input. Here two numbers. Suppose I am going to use N1 and N2 there. Then I can use my parallelogram and say I am going to input N1 and N2 there. Then my next step, I am going to add them together and assign to total. So, how I am going to express that I am adding the two numbers? You know, we can add the two numbers using N1 plus N2, or if it is correct, if you can write N2 plus N1, it is also correct. Now, I am going to store the addition in total. How can I say that? Total. So, I am going to store the value in total and I put an equal sign to indicate that I assign them. So, what is this? This is a calculation, a computation. So, this is a process. So, in order to indicate a process, we use a rectangle. We use a rectangle. So, it should be a rectangle and I have to say I am indicating the flow. Remember, all these symbols should be connected with arrows and arrows display the program flow. Now, as my last step, I have to display. Now, the total is inside the computer. We can't see that. So, we have to tell the computer, please display me the total. So, how can I say that? I have to indicate it also using an output symbol. So, I use an output symbol. I have to draw a parallelogram and I have to indicate the flow, then say display or output. Here I have written in my algorithm, I have written as display. So, here I will use it as display. Display what? Display total. So, I am going to write display total. Now, have I finished my flow chart? No. I have to indicate now I have stopped. So, I am using my rounded rectangle, then I have to write stop. Then I have to connect the other arrow. Now, I have my flow chart for the given algorithm. Now, see, I have start and stop. Then my input is given, input 2 numbers or input n1 and n2. Total is there, addition is stored in total, and I am going to display total, and this is the way I have indicated my termination or stop. So this is the way you have to represent an algorithm using a flowchart. Now can you guess what is the control structure described here? Here this program flows step by step. So this is an example for the control structure sequence. Okay. Now I will give you another example. Can you see? Last time we learned how to calculate the age of a person. Now shall we try? Can we draw a flow chart to that also? There we have to input the year of birth and current year, calculate age by subtracting year of birth from current year, and display age in years. So you can draw a flow chart for that, and you can correct it. You can, as we have described, try to draw the flow chart to this question. Input year of birth and current year, calculate age by subtracting year of birth from current year, and display age in years. Try to do that. You can do it during your free time. Okay. Now we will learn how to draw a flow chart to our next control structure. You know it is selection. I will give you a question. The question is, you will remember last time we learned that we have two numbers. We have to compare these two numbers and find the largest number. So first of all, if we are going to draw a flow chart, our first thing is we have to indicate that we are going to start. So we have to use our symbol for start, that is we can use a rounded rectangle. We can use a rounded rectangle to indicate that we are going to start the program. So draw the symbol very correctly, because in the exam we will be marking, because you have to know what are the symbols. These symbols are used worldwide, so you have to know these symbols and use these symbols correctly. Otherwise your programs won't be understood by the others. First start, then we have to input our numbers. We will write input 2 numbers. For this also I will use input n1 and n2. We can use any letters. Don't think that it is the only n1 and n2 can be used. You can use any English letter for this. So I am going to input. So my symbol should be a parallelogram. Symbol should be a parallelogram. Then don't forget to put the arrow. Now I have to compare. How can I compare these two numbers? You know, in mathematics we can compare these two numbers using if n1 is greater than n2. Or you can use n2 is greater than n1. It doesn't matter. I have two numbers. I have to find the large number out of these two. Now I have to indicate the symbol. Can you remember the symbol? To make the decision symbol, we use a diamond shape. So a diamond shape can be used. And now suppose if n1 is larger than n2, can you remember those two arrows were there? There were two arrows in this symbol. So if n1 is larger than n2, if it is correct, I can put here yes. If n1 is larger than n2, if it is correct, what is the largest number? Then the largest number will be n1. So you have to display n1. Here I will use display n1 inside the parallelogram. Display n1. Suppose n1 is not larger than n2. That means here I have to write no. Remember to write yes and no when you draw this decision box. Otherwise, we have seen many students, they have forgotten to write yes or no. So, we can't give marks for those flow charts. Then, if n1 is if that condition is false, if the answer to the question is no, we know what is the larger number. We have to display n2. Now we have our display number is there, display n1 and display n2. Now we have to terminate or finish the flow chart. Now I am drawing the stop symbol. Now we have to connect these two symbols with a connector. Can you remember the symbol we used? A connector. So I will use a connector and use this. Don't forget to draw the arrows. Now we will look at this problem once again. We have to find the larger number out of given two numbers. First we drew start symbol. Then for the input two numbers, you can use input n1 and n2. I have input two numbers. Then we check whether n1 is greater than n2. If it is correct, we move along the yes line. Then n1 is the larger number, so we display n1. If it is false, we have to move along this no path. So here we select. That is why this control structure is called as selection or branching. We can't go along these two paths. You have to select only one path. Then after displaying the answer, we have to put a connector and we have to add one arrow to the stop. So you can find out problems like this in your papers. There are certain questions. Try to do the questions and draw the flow charts to those questions during this time. Okay. Now as our last structure, we will find out how to represent a repetition control structure using a flow chart. Now this is our question. Can you remember our question? We are going to find whether a number is odd or even. We are going to find whether a number is odd or even. Okay. Now I will start from my start symbol. Now you know start. For start we use a rounded rectangle. Rounded rectangle, then I have my arrow. Now what should I do? I have to input a number and say, whether it is odd or even. I can use that. So I will write it like that. Input a number. So I have to use the input symbol, input number. I will write number here. Okay, input number. Now, how can I find whether a number is odd or even? You know, odd numbers, 1, 3, 5, 7. Even numbers 2, 4, 6, 8. So, how can I find whether a number is odd or even? Can we find a number by dividing it by 2? If I divide 4 by 2, the answer will be 2. So we can't. So what is the way? We have a computation problem here. So I have a function here. We have a function called mod. You may have learnt it. Mod. It gives us an answer. Suppose we divide a number by 2, we get a certain value. But if we use mod, we get the remaining value. Suppose you mod a value by 2, then you will get, suppose we will use 5. 5 mod 2. Here I will use, if you use 5 mod 2. Now I will get the remaining answer. Divide it by 2 and what is the remaining answer? 2 into 2 will be 4 and I will get 1 as the answer. Suppose I mod an even value, 4 by 2, I will get 0. So any odd number, when it is used by this mod function, we will get as the remaining value we will get 1. If we mod any even number by 2, we will get 0. So here I can use that to get my answer. So I will use this. Suppose I have my number with me. I am going to find the remaining value I get by using this function. So I will use another value. I can use y. Now my number is number. I will use the function, learn this function, it is called as mod, M-O-D, mod, then mod 2. That means my answer is stored in y. If it is an odd number, I will have 1 in y. If it is an even number, I will have 0 in y. So this is a calculation. So I am going to do this. I will use this value. I will calculate this value. So this is a process. So I use a rectangle. Now I am going to find out whether my value is equals to 1 or 0. I can use that one inside a diamond. Whether my value, I have used y, whether y equals to 1. If 1 equals to 1, what is the value? If y is not equal to 1, I can use here no. If y is equal to 1, that means the remaining value is 1. So my number should be an odd number. So I should display the message. Message inside the parallelogram. Display, my message is odd. Display odd. If it is not equal to 1, I have to display that. So that is an even number. I have to display even. Now you may also come across this kind of problem. First write the message inside the this symbol, otherwise you won't be able to finish that. Within that you keep that symbol, display even. Now I have to stop my problem. So I use a connector here. And don't forget to draw the arrows. Now I may stop my problem by indicating the termination symbol stop. Now we will once again go through this. Now I have drawn a flow chart to this given algorithm. I have used start and stop symbols to indicate the start and stop. I have input a number input a number is inside the correct symbol, which is a parallelogram input number. So this kind of thing is we have to find out how can we calculate odd or evenness of a number. I have used the function mod here. Learn that function. It gives us the remainder of, when we divide a number by 2, it gives us the remainder. So I have used the process symbol rectangle. Then here is my condition is given. Now check whether this is correct or not. Now what happens here? Now have I used the -1 here? No. Now when to use that? Here before going this, before indicating the stop value, now this will be worked only once. If I draw it like this, this will be only worked once. But I have to do that. I have to go once again to this input number. So what happens here? When I display even here, I have to use whether I input -1. So what is the most suitable place to indicate or show my termination part, or where should I put -1? You can say if in our first attempt I enter a number, now you get odd or even, and then there if I enter that condition, it will work once. The most suitable place is, can you guess what is the most suitable place to indicate the counter? We call that as a counter. Here this should happen repeatedly. This should happen repeatedly. So in this flow chart, this will happen only this time. Then if I put my stop symbol here, only one number will be displayed. So how can I do this for several numbers? It can be done like this. Here the program will give me several times to indicate input number. If I use this, please you have to draw correct straight lines here. This should be like this here. But how can I say, how can I check whether my input number is equal to -1? The most suitable place to indicate that is, I think it should be here. If my first attempt, when I input a number, if I check whether this number is -1, it should stop displaying that. So I will use here this part. Here, once I input a number, if I check whether this is equal to, now whether the number is equal to -1. So what will happen here? When I input a number, I check whether my number equal to -1. So what is my condition? If I enter -1, the program should stop. So I can use my stop symbol here. If it is not equal to -1, my program should go. So you have to use correct symbols here. I will draw it again because I have to show that this symbol is a diamond symbol. Otherwise, many won't understand what is the symbol. So you have to be very careful about your symbols. So I have to indicate like this input number. Then if it is no, now only I will check whether my mod symbol can be used here. Earlier I have written it y equals number mod 2. Okay, now here. Now you see here, this is the way repetition works. If the number is equal to -1, here -1, number equals -1, equal sign and -1 should be here, -1. If the number equals -1, the program won't go, it will be stopped. If it is not equal to -1, we go until someone enters -1, or you can change this problem. If someone enters a negative number, this could be stopped. It is up to you. This is my design. You can change it as you wish, but you have to maintain this. So this will go repeatedly. This will happen until -1 is entered as the number. So we have learned today how to draw flowcharts to display 3 control structures: sequence, selection and repetition. Please try to find questions in your past papers and come with the answers for flowcharts. So until we meet at another time, goodbye.